Hey guys, it's Miss Wilkie, and today we're going over inductive and deductive reasoning, and this is lesson 2.2. Alright, so inductive reasoning, it uses specific examples to come up with a prediction. So you got some examples down below. A lot of these you'll see as patterns. So right here, to get from 4 to 8, we had to add 4. To get to 8 to 12, we add 4 again. 12 to 16, we add 4. So we know our last thing we should be adding 4. So 16 plus 4 would give us 20. But the other ones are going down this time, so we're subtracting from 20 to 15. We do minus 5. 15 to 11 is minus 4. 11 to 8 is minus 3. So then over here at the end, we want to do minus 2. So 8 minus 2 is going to give us 6. And then the last one's days of the week, so it's Monday, Tuesday, so we know the next one should be Wednesday. Alright, deductive reasoning, very similar, just a little bit different because this one uses facts, rules, definitions, or properties to reach logical conclusions. So an example on this one, we'll see more about this later, but this one says, on Fridays we eat pizza. Today is Friday, so you can say that today we will eat pizza if you combine the two. Alright, our next section here is about conjectures. A conjecture is an educated guess based on known information. So you're guessing based off of things that they've already given you. So number 1 says, make a conjecture based on the following information. It says point B is in between A and C. Point B is equal distance to A and C. And they're asking us to make a conjecture. Most of the time you'll want to draw a picture. So it says B is between A and C. And it said point B is equal distance from A and to C. So that means from A to B and from B to C it should be the same. So our conjecture here, if it's equal distance, we can assume that point B is going to be the midpoint. Alright, our next word here is counterexample. So a counterexample proves that a statement is false. So we're proving it wrong. Number 2 says, what is a counterexample of the following statement? Provide a written answer and a picture. So the statement is, any two lines are always parallel. So we're trying to prove this wrong. So by doing so, I'm going to draw one line here, and we want to prove it wrong. So if we wanted it to be parallel, we'd run one go in the same direction right next to it, but we don't want them to be parallel. So I can draw a line going any other direction, and they won't be parallel. So this is a counterexample. It's proving it wrong. They also want a written answer, so we can say that two lines could intersect. And that would prove that statement wrong. Alright, so we're going to go a little bit further into deductive reasoning. There's 2 laws. One of them is law of detachment, and the other one is law of syllogism. Okay, they're very similar. They've just got a slight difference in it. So let's go ahead and look. Law of detachment says if P, then Q is true, and P is true, then Q is also true. So let's look at an example and we can see how easy this is. The example says, if it's raining, then it's wet. On Thursday, it was raining. So our conclusion is, therefore, it was wet on Thursday. So the way we got to this conclusion is by taking out the middleman of these 2 statements right here. So if you look at both of the statements, they both mention that it was raining. So if we take out both of those statements, you can see that our conclusion is made of what is left from those 2 statements. So here, our remaining parts is, on Thursday, it was wet, and that's where our conclusion comes from. So looking at number 3. Number 3 says, use law of detachment to determine a conclusion. So our 2 statements say, if the measure of an angle is greater than 90, then it is obtuse. Second statement says, measure of angle ABC is greater than 90, and then we're looking for our conclusion. So again, we're trying to find what they have in common. So if you look at both of them, what they have in common, they're talking about the measure of an angle is greater than 90. So here on the second one, we've got measure of an angle right here, and then we've got greater than 90 right here. So we can take out all of those parts because that's the same, and our conclusion is whatever's left. So our conclusion here is obtuse and this angle ABC. So we can say that our conclusion is that angle A, B, C is obtuse. All right, so for law of syllogism, again, it's kind of similar. We're doing the same type of thing. The example here says if you are a ballet dancer, then you like classical music. If you like classical music, then you enjoy the opera. Again, we're finding the middleman and taking that out. So both of these statements say that you like classical music. So if we take out that middleman, our conclusion should be based on whatever is left. So our conclusion should be based on what is left, which is the red underlines. It should be if you are a ballet dancer, then you enjoy the opera. So our last example here, we're using the law of syllogism to determine a conclusion. So let's read our two statements. It says if two lines are perpendicular, then they form a right angle. If a right angle is formed, then the measure is 90. So again, we're looking to see what they have in common. They both say that they form a right angle. So we're taking that out because they both have it in common. And we're using whatever is left over. In this case, it would be two lines are perpendicular, then the measure is